Good morning or afternoon. Welcome to my help video session. This Unit 3, Lesson 4 focuses on estimating margin of error using standard deviation. Yes, this one can be a doozy because there are a lot of steps, couple of formulas you need to know, but regardless, we will tackle these practice problems together. If you are following along, this is, like I said, Lesson 4 of Unit 3 of your Algebra 2A course. So let's get started. All right, this first example focuses on a practice problem where you are looking for the margin of error. Now remember, margin of error, you could think of it as how much could you be off from the true population value, right? So you could think of it as like wiggle room around your guess, right? So whatever guess is provided in the problem, you're looking to see how much you would be off from the actual value. So the problem states a poll predicted that 68% of voters plan to vote for the current mayor of the upcoming election. If the poll had a standard deviation of 4%, what is the margin of error? All right, so we are given 68% is our prediction, right? So that would represent our data point, right? And we're trying to figure out how far off that 68% is from the true population value. Now, if the poll had a standard deviation of 4%, we want to find, so it says what is the margin of error. So we are looking for margin of error, which I mentioned previously. And to find the margin of error, we're going to use this formula right here. Margin of error is equal to z times our standard deviation. Okay, and our z stands for our z value. Okay, it stems from our standard normal distribution, right? And it's the confidence level you want for your margin of error. Let's just go with our 95% confidence level. Okay, so that's pretty standard. So you can think of our z value always going to be 1.96. Okay, so whenever you see your z value, plug in 1.96. Now, we also are given our standard deviation, which is 4%. Whenever you plug in your percent, you do need to convert it to a decimal. So in a calculator, you can divide it by 100 or move the decimal over 2 places. So it would be 0.04. And to find our margin of error, we're going to take our 1.96 and times that by our 0.04. And when we do that, we do get a decimal, which is 0.0784. Now, if you notice, they want us to give it in percent form. So what we're going to have to do is you can either times it by 100 or move the decimal over 2 places to the right. So we end up with 7.84%. Now, like always, make sure the answer is the correct place value. So if you need to round to the nearest tenth, it would be 7.8%. Our next problem states that a survey of house cats found an average weight of 8.4 pounds. If the margin of error for the survey was 1.2, what was the standard deviation? All right, I'm going to circle my key info here. So we have 8.4 pounds. We are given the margin of error, okay, which is 1.2. It wants us to find the standard deviation. So this particular example wants us to find the standard deviation. Okay. So to do that, we're still going to use this formula here, our margin of error formula. And remember from before, our z value is going to be 1.96. Okay, we are just going to do that common 95% confidence level. Now, we are not given our standard deviation, so this is what we're looking for, but we are given our margin of error, which is 1.2. So to find the standard deviation, we need to use our inverse operations. We are going to divide both sides by 1.96. So we end up with our standard deviation is equal to whatever we simplify here, which we get 0.612. So to answer our question, our standard deviation is approximately 0.61 pounds at a 95% confidence level. The next example is an example of a problem where you are looking to find the standard deviation of a simulation. Okay, so remember a simulation, we have the population, which is your real world group that you want to know. Okay, and then we have our sample, right? Those are the simulated trials or outcomes that you generate. Right? So these here, or this table right here, represents our sample. Okay? And whenever we're looking to find the standard deviation, we're going to use this formula right here. And this is the standard deviation. The square root of your proportion, your sample proportion, times 1 minus your sample proportion, all over or divided by your sample size. So the two pieces of information that we need to grab from our problem today is the given proportion and our sample size. And with those, we can find our standard deviation. So reading through the problem, a politician asserts he has 80% support in his district. A sample of 100, that's useful. District residents reveals his support is 65%. 100 trials of sample size of 100 are simulated, assuming a sample proportion of 0.65. Okay, so already I can kind of identify my key pieces of info. So I'm going to plug this 0.65 in for my P. I'm going to plug in the 100 for my N. So I get standard deviation is equal to the square root of 0.65 times 1 minus 0.65 divided by 100. And what I'm going to do is I'm going to plug that into my calculator. And when I do that, I get my standard deviation is approximately 0.0477. Now, the question says, estimate the margin of error using that standard deviation. And so to do that, our following step after we find our standard deviation is to plug it into that standard or that margin of error formula, right? Because that is what we're looking for. And remember, our Z is always going to be 1.96. Okay, don't forget 1.96. I will highlight that in red on your study guide. Okay, so we take 1.96 times our 0.0477, and when I do that, we get a margin of error in decimal form, approximately 0.0935, which if I converted that to a percent, I would get 9.4% margin of error. All right, so we are going to keep plugging along here. This is another example of finding the margin of error. But we are not given the standard deviation, right? So we have to calculate that standard deviation based off of the simulation. Okay, so to do that, we got to use that formula. Our standard deviation is equal to the square root of P stands for your, right here, your proportion, sample proportion, and N represents your sample size, which once again in this problem is 100. So let's plug in what we're given. So we have 0.98 times 1 minus 0.98 divided by 100. And you can plug this in exactly how you see it in your scientific calculator. Just make sure that when you use parentheses, you close them, right? And your division symbol goes underneath these both of those numbers, right? Because PEMDAS, your calculator does PEMDAS for you, so you need to make sure you plug it in correctly. But when you plug this in, we get 0.094 and so on. So now, step 2, since we're looking for the margin of error, we're going to have to plug that into that formula. Remember, your Z value is going to be 1.96. So our margin of error is equal to 1.96 times our 0.094. And what we get is 0.184 approximately. And I'm going to convert this to a percent. So I get 18.4%. All right, so this problem looks crazy intimidating because there's so many words, right? So what I'm going to do is I'm going to follow my cubes where I circle my numbers, underline my question. I'm going to box up keywords and then eliminate everything else because words are scary. So that being said, let's go ahead and tackle this problem. So based on a poll of 100 small business owners, a real estate development group claims that 67% of small business owners are in favor of the construction of a shopping mall in the area. A resident crime prevention group claims that the poll is not valid and that only 33% of small business owners are in favor of the construction of a shopping mall in the area. To determine whether this sample supports the population proportion of 0.67, a simulation of 100 trials is run, each with a sample size of 200 and a point estimate of 0.33. The minimum sample proportion from the simulation was 0.19, and the maximum sample proportion from the simulation was 0.58. The margin of error of the population proportion is found by estimating the standard deviation. What is the interval estimate? Okay, so we're finding uppers and lower bound of the true population proportion. Okay, and our answer is going to be decimals today. All right, so they're giving you a whole lot of numbers, but you need to be able to identify which numbers you need. Now, we need to calculate our standard deviation. And remember, our standard deviation, we need two pieces of information, which is our population proportion and our sample size. Okay. So right away, I like to box up what each of these numbers represent. So 100 small business owners, 67%, so percent is circled, 33%. Okay, so this is the claim. This is the possible other claim. Okay, I'm going to cross everything else out. By words. Now, to determine whether this sample supports the population proportion of 6.7 or 0.67, a simulation of 100 trials is run with a sample size of 200. So this is our sample size. So we're going to plug in our 200 for N. And a point estimate of 30.33. Now, we're trying to see if this population proportion is true. And to do that, we're running a simulation where the sample size is 200 and our population proportion for that particular problem is 33% or 0.33. So we're actually going to use the 0.33 here. So when we plug in, we have 0.33 times 1 minus 0.33 all over 200. And when we do that, we get our standard deviation is approximately 0.03325. Now, step 2, we want to find our margin of error. And to do that, we take our Z value, which we're going to be using 1.96, times our calculated standard deviation. And when we do that, we multiply them together. Our 95% interval estimate or margin of error with 95% confidence is plus or minus 0.06520. So now, to find the upper, we take our 0.33, we add our 0.06520. To find our lower, we take 0.33 and subtract our 0.06520. And when we calculate that, our interval estimate is going to be 0.2648 to 0.3952.